Okay, hello. Just before Christmas, I was recording a few screencasts about nested functions, and with the anticipation that closures are coming to C, and that nested functions have also been recently made safe in GCC. So I'm going to just put together a little demo of writing what I think is a useful nested function abstraction. So I guess we'll call it, let's call it nested.c. Is this big enough? Let's up it a bit more, and I guess we'll probably need standard io.h, won't we? And we'll need a main, but I don't think we'll take any arguments. Okay, so what I'm going to do is I'm going to write a thing to read in a file. Okay, so what if we want to read in a file? Read, let's say it's a config file, right? And we want the file to be portable, so we want to specify the directory as like you know, the file name is always going to be the same, but it could be in any directory. So we're going to say something like my dir, my file, right? That's what we want. Let's say, and we want to read the config file and do something with it. So why read a config file? So ordinarily we do something like this, maybe, but why do that when we could go process config file, and what if we had processor? Okay, and then we've got my dir and my file. And if res is less than 0, then we'll return 1, meaning error, otherwise we'll return 0. Okay, so we don't know what a processor is yet. What's our config file going to look like? I guess we could have, like, my point I think is that you can wrap up some parsing or whatever it is you want from the config file. You could even set a context. So let's say that our config file is going to be a few lines, like line 1, line 2, and I guess we're going to read these in and do something with them. Like, so if it equals a certain thing, we'll do a particular function. Okay, fine. So why don't we write process config file? Okay, so it needs to be an int, and it's going to take an int processor, which takes a char. No, it doesn't. It's going to take a file, isn't it? It's going to take a file f. Okay, and then it takes a char directory. Whoops. And it takes a char file name. Okay. So now what we're saying is we're going to call processor, which we'll define down here, with an open file. So we want to open a file, right? File stream. No, we'll just call it F, I think. So that's F open. But wait, we don't know what directory and file name are. So we need a single file name. How are we going to get a single file name? We need to put them together somehow, don't we? Oh gosh, now we need to allocate. Okay, so let's allocate a string to be the combination of them both. Okay, so this is like a cleanup, automatic cleanup for allocation. So this variable will have free string called on it. Where's free string? We can define it here. And the interesting thing is it has to be a double pointer, because this passes in, the way this works is it takes the address of this variable and passes it to free string when the scope exits. So we're going to call free on what's pointed to by string. So we can do it there. We can also lift this up to the outer scope, but let's leave it in here for now. Okay, so now we've got a path. Now, just at this point, before I allocate the memory, I just want to talk quickly about another thing coming, is defer. So if we had defer, we'd be able to do this. So this is coming in the new standard 2. So we wouldn't need this, and we wouldn't need this. We just need this, and that's pretty nice, I think. Okay, so for now though, we need this. So now we're going to use ASPrintf, which I think might be in standard IO, but I've got a libc manual hanging around here somewhere. So ASPrintf. Let's turn on truncate lines so we can read the thing. Where is this defined? Can't see. So I think it must be defined in standard IO. Free will be in standard lib though, won't it? So we do need free. Okay, so ASPrintf will print to the path. It'll allocate the storage, and we're going to make a thing like this, and we're going to have directory and file name, boom, and now if len is less than 0, then return -1 because it failed. Otherwise, we're going to use path, and we can also use that, can't we, to open the file. How are we going to close the file? We could do it this way. So we'll just go close file. So we need another one of these. Close file. Again, we could use defer if we had defer. Oh dear, if I could type, I'd be dangerous. Okay, so now we have a file, it's going to automatically close. We're going to call processor with that file. Okay, and we're going to, let's take the status and we'll return it. But at this point, all of the file will be closed, and the path will be removed. Like the path memory will be removed. Okay, that's perfect. We just wrote this very generic tool that we could use over and over. in all sorts of places to process a file. One of the things that I do is to then go add mode to this. So instead of having something that's tied to one read mode, I pass the mode in, and then we're all good. Okay, so now we need to write the processor though, and we're going to process this config file like this, right? You'll notice that this doesn't care at all about the config file, so let's put that up there. This could go somewhere else. This could go in, utilities file or a library. And one thing I wonder is that when this stuff comes, will library maintainers for things like libcs start adding optional things for callback styles? This path name problem, I think, is quite a big problem. Anyway, okay, let's finish this off. So let's make a processor, and it's going to take a file, and so let's call it config. Okay, and then we're going to read from the file, aren't we? So can we use gets? Is that okay? Gets. It's fgets, isn't it? Fgets. Let's go up to here. Yep, there we go. Fgets. Oh, I wonder if we can use fgetLine. fgetLine, yeah, look at that. So we can go size t red equals config getLine from line buff, and what's n? Before calling n, we should place in line point the address of a buffer n bytes long. If this buffer is not long enough to hold a line, getLine stores. Let's just make this a bit smaller. If this buffer is long enough to hold the line, getLine stores the line in this buffer. Otherwise, getLine makes the buffer bigger using realloc. Right. So we've only got to make a thing big enough for a few bytes. So let's just say 10, I guess. Line buff equals malloc 10. Okay, so get line and then size t n. Right. So that's 10, and then the stream is config. Okay. So then, how does this signal? When getLine is successful, it returns the number of characters read. This function, this value enables you to distinguish null characters that are part of the line from the null characters inserted as a terminator. This function is a GNU extension. If an error returns or end of file is reached without any bytes read, getLine returns -1. So while red is greater than -1, red equals getLine and line buff 10 config. Okay, so if red is greater than -1, then we should be able to go string comp line buff, comma, I don't know, let's just do it like this. So if equals 0, then printf got line 1. Okay, we'll reorder these in some test data. Okay, we'll just do 2 lines for now. So you realize I'm parsing the line. It's all good. And actually, oh boo! It would be good to just have this, wouldn't it? So have a single loop. So we could go s size t red equals 0, and then we could do this. So I think that's a better. I don't need the second. Oh gosh, that was annoying. I don't need the second declaration. Right, so we're going to read into the line buff. It's going to automatically reallocate. We are going to make sure that gets cleaned up as well. And now you see why we might want to lift the free string above here. Let's tidy up this. It's great when oh, it'd be good if I finished my sentences, wouldn't it? It's great when we're full screen, but it's not so great when we're not. Okay, so that's fantastic. And now we've got a free string that we can use. You see why defer is a bit better. You don't need these functions. The tendency to make a dependency here on another function is big. Anyway, hey-ho. So now we're testing for 2 different types of line, and we're going to return 0. Okay, so I love putting in a little end marker so you can see that the code is ended. Okay, so that all makes sense, right? Now let's I'm just going to get in at this. Okay, now let's use GCC, and if I can remember, see, I've got a lot of GCCs installed. I think we're going to use 14 because that will be GNU 23, C standard 23 by default. But we also need trampoline impl equals heap. And I guess I'll show you what happens if you don't do that. Okay, we've got a bunch of errors. So it looks like we need string.h going in no particular order. Because we use string comp, of course. Okay. Okay. So in function close file, did you mean p close? No, I didn't. I mean f close. Okay. Oh, yeah, look. We need some file names. So, char mider equals dot slash and char my file. Oh gosh, Nick, type properly. Equals my.config. Okay, and char mode was wrong because that's actually a string, isn't it? The mode. Okay, now we've only got one error. parsing argument 2 of getLine makes a pointer. Yeah, because let's put this up here. Sorry, I can't remember what it was. Oh, it's a size T, not an S size T. So we can use it here. And then we want the address of that because it's going to put that in, I guess, as the okay, so now let's make a config file. What's it called? my.config, and we'll have line 1 and we'll have line 2 for now. Okay, and we'll call GCC right, we'll call nested. Okay, we didn't get anything, so why not? We made a line while red is greater than -1, and then call okay, so let's print this out in our processor. Oh, yeah. Okay, so we want a ZU instead. Okay, that looks like there's a bit of a bug, doesn't it? Why is that? So obviously it shouldn't be that much. There's an empty line. So you'd expect red to be 0 and then -1, wouldn't you? I wonder if we made size 1, what happens? Same thing. Get line, line bar. Okay, let's go look at this again. Reads an entire line from stream, storing the text in a buffer, blah blah blah, and the buffer address in line pointer. Did we give it line pointer? Yep, we did. Line buff, the address of line buff. Okay. Before calling getLine, you should place in line pointer the address of a buffer. Yep. Allocated with malloc. If this buffer is long enough to hold the line, getLine stores the line in the buffer. If you okay, it returns the number of characters read. We're not interpreting. Well, that's very interesting. So you'd expect red to be -1, wouldn't you? But let's cast it to an int and see what happens. Okay, fine. That seems a bit odd to me, but anyway, there we go. It's working. So if red is, let's do this. We're going to make iRed int red, because obviously for some reason that I don't want to go into right now, the -1 thing isn't working. So we'll say iRed Okay. So if iRed is greater than -1, then we're going to string conf line buffer. Okay, so we should be able to printf the line buffer. Okay, we've got line 1 and line 2, and that is because they've got carriage returns on the end of them, I guess. Right, so let's take out the printf. And let's run it again, and there we go. So this is an unusual config thing. So hey, what we promised to do was change these around. Right, we should just be able to run that, and we can see that we've got line 2 first and then line 1. So perfect, right? So we wrote a very simple generic callback based processor that gets rid of all of the opens and closes and all of that. Now the thing is, what you can do is take this even further and make this more generic. What if we had the ability to specify multiple path steps? So you could have an endlessly deep thing. So that's what I was doing the other day. Instead of doing this, I have a file name template, and then I have a variable argument list, and the file name template we can pass through to vs printf, and so yeah, that all works just fine. So what we would do is go va start ap, and then sorry, we need a va list ap, and then we call va start with ap, and the file name template, and then we call vs printf with, instead of the directory and file name, we call it with ap, and then we call va end. On AP. Okay, so now instead of doing this, we can do this. Hooray! Oh, we need the variable args stuff, which is standard arg, I think. So hash include standard arg dot h. And oh gosh, that's just another problem, isn't it? It's not vs printf, it's va printf. Yeah, vas printf. Where's it gone? Yeah. There we go. Same thing. And so soon you realize that you could do even better. So what if you wanted a very generic thing that takes a file name? Well, then we have a file name template and the VA stuff. So let's lift the VA stuff from here. Whoops, let's lift the VA stuff from here. Okay, like that. Okay, so now we've got the ability to do with file name. Okay, perfect. And then we'll return processor with what did we call it? Path. So now instead of this, we want this to call this. Well, how can we do that? Well, what we do is we take we cheat a little bit. So we'll go with file name 1. We'll just copy this argument list. Instead of that, we'll have a VA list AP. I think we'll do it like that. So we'll call the processor. We won't call VA end. Okay, so we'll do that outside. And of course, I'm sure that you realize we could wrap this up in other ways, but there we are. So instead of doing that, we'll just do this. So we'll call with file name 1 with the processor, and then file name template, and then the AP. And we need a result temporarily, don't we? So now instead of calling, so we can call with file name from other things, but we can also call with file name 1 from here with file name 1, and this will be all wrapped up in yet another processor. So we need file proc, and this is going to take a file. No, it isn't. It's going to take a file name. Sorry. It's going to take a path. So that's what we called it, right? And then it's going to call processor, and it's going to return ret, and we will copy these parts and then we'll call with file name 1 with our file proc, which is then going to call the actual processor, and the VA, the file name template, and our VA list, and then we'll call VA end on AP, and we'll take a ret in the meantime. Okay, boom. So you can quickly make sort of very powerful generic tools that wrap up a lot of boilerplate annoying stuff like opening and closing files and you know, all of those things. Okay, yeah, sure, we have defer, but this is even better. So defer makes these, or cleanup attributes make these, yeah, they're easier to write, but now you're not spreading your code absolutely thick with these kinds of things, and instead you just get to write sort of simpler code. We could, of course, make a getLine abstraction that abstracted away all that malloc stuff, right? So I don't know. I think it's pretty exciting. I just wanted to do it completely from scratch because I thought it might be interesting with all of this trampoline stuff. By the way, I did want to show you that one last thing. What happens if we take this off? So what we get is this. It requires an executable stack. You can turn that on, but then you're making your stack executable, which means you can buffer overflow into the stack, and boom, you've got a whole bunch of security problems, which is why it's so exciting that the GCC people have implemented heap-based trampolines. Now, apparently they're relatively slow under some conditions, but this sort of thing, you're doing tiny amounts of work, so you're not calling it in a tight loop, and I really don't think that's a big concern. And anyway, closures will come. They'll make it all much simpler, much faster, and by making it choosable how you deal with things instead of having fixed implementations. So there we go. That's all I wanted to show. I thought it'd be a laugh. Thanks very much.